Today we're going to look at absolute value functions. Now, with absolute value functions, all my students last year did a really nice job of knowing what they look like, but this question was on the regions prior, and a lot of people had issues with the explanation part, how decreasing the coefficient would affect the graph. So we're going to look at this question because it's important to be able to voice your opinion and your facts in words. Now this was a 3-point question when it was done. And they have the absolute value function. So the first thing we're going to do, I'm going to get the graphing calculator up, and we're going to show you how to graph an absolute value function on the graphing calculator. So the first one was the absolute value of x. So if you hit your math key and scroll over to number, you're going to see the first option is ABS. ABS means absolute value function, obviously. So we're going to hit X, enter, okay. Now, mine gives it as the bars, but usually what's going to happen is you're going to have an ABS with regular parentheses. So I'm going to put my X in, and I'm going to hit enter to input that. Now that was the first graph. And we go back and take a look, the second graph was 1/2 X. So we're going to graph this one as well. And with the 1/2 X, we're going to do the same thing. The 1/2 is inside the absolute value function. So we're going to hit ABS. And then we're going to make a fraction, 1 divided by 2. Okay. And we'll put our X in. Now, generally I would say take your fractions, put in parentheses. But we do the absolute value symbol right there, so we're not going to worry about that, because that is treated like a parenthesis. So hit enter. And it's going to give us our second graph. Now, notice that y1 is our first function and y2 is the second one. So, if I go to my table, hit the second and graph, I'm going to go to around and try to get 0 centered, just so I can find some differences between this. Now, you're going to notice that there is a place where they all meet, what happens to be 0, 0. So, 0, 0 is where they all meet. Now, first thing I'm going to do is I'm going to graph the first graph. So I'm going to go back. I have 0, 0, 1, 1, 2, 2, 3, 3. So my points for my first graph seem to be going in this general direction, and they keep increasing by 1 each time. Now on the negative side, for the first one, they do the same. Now, like I've always said, the more points you put in, the better. If you see a pattern with a linear or absolute value function, follow that function. So I'm going to go ahead and I'm going to graph this line. And it also wouldn't hurt to put your table on the paper as well. Now I'm going to put my equation, y equals absolute value of x. Now, let's take a look at the second line. And with this one, over here, what you're going to see is that from one to the next, we're only going up by halves. So, taking that knowledge, we're going to go back and graph the second one. And I'm going to do that one in green. Now, you can do the halves. Sometimes it's easier just to do the whole numbers. And for this one, we're kind of got a slope of 1/2. So it's for every 2 we go up 1. Now, same thing on the negative side. You don't have to put the decimals in. You can stick with whole numbers if there are a lot of them you can use. Now, here's our second line. And again, arrows, put a label, 1/2 x. Now, they want us to explain this. Picture's great, labels are great, but we only get 2 points right now for having our graphs and labeled correctly. So if we take a look, based on what we see here, really the shape doesn't change, but what does change is is that we have a graph that opens up more when you have a value that's less than the coefficient in the first one, which is 1. So we could put something like that a graph where a is less than 1 is more open than when a, that coefficient, equals 1. So for this right here, it's very important that we put an explanation and talk about how the change has been made and what it does to affect the graph.